Welcome to our Saturday evening session of the 2012 Extraordinary Technology Conference. Once again, we have Marko, Rodin, and very much one of the favorite speakers for this conference for several years now. He goes back years and years. I remember him coming up to conferences in the late 80s and showing some of the incredible mathematical work he was doing. At that time, everyone involved was really impressed. We still are. And one of the things that's really remarkable about his saga is that this stuff has practical application. And that's truly remarkable in a world where we have so many theoreticians and so much math covering the walls everywhere. Marko wanted me to make sure to mention that at this point he needs to find a new base of operations, preferably a place near water. He also wanted us to know that his work has been patented by a head of future operating systems at Microsoft. So that's very significant news. We don't know the entire significance of that, but he's been in communication with this person. He's still looking also for a sponsor to produce a book, a video, and a children's curriculum. All of this on the vortex-based math that his unique achievement and trademark and something that will change the future of this world. Let's welcome Marko Rodin.
Yay. Thank you, Michael. That was perfect. Thank you, everybody, and thank you, Steve, for allowing me to be your guest. This is a dear friend, Willie. Willie, stand up. And I'm going to be presenting after him. I'm going to be discussing the, oops, broke it, the patent and the documents. And Willie, what will you be sharing?
Well, solid state centrifuge that I came up with, a little bit of background about who I am and what I do, and then also where I would like to help see this go.
Okay,
This technology.
and and what are these?
These are slugs. Basically, I guess there was a problem, or people were having a problem with understanding or being able to recognize a bias or monopole magnet, and I've been able to duplicate it. Oh, sorry about that. I've been able to duplicate the bias or monopole. So anyway, I just wanted to show that really quick.
2 years ago, Jamie, right here at TeslaTech, held up a Rodin coil with a magnetic tester with the coil on, and he says it was only showing, he couldn't find, was it a south pole?
He couldn't find a south pole.
He says there's no south pole, no matter what. And after the conference, we went to Jamie's house, and me and Tyler played in Jamie's lab, and I took some drill bits, high carbon drill bits, and with a load of a light on it, I put it inside the coil and just flicked the switch back and forth really fast. And then I took that now permanent magnet out, or semi-permanent magnet out, and put it to the magnetic tester, and shockingly, there was still no south pole. We filmed this and shared it. Mm-hmm. And then a challenge was made by Russ. Russ replicates our experiments on YouTube. He couldn't duplicate it, and no one else was able to duplicate it, other than Jamie using the same coil himself. Boy, I can feel something going on in this. What is that?
I don't know. It's probably just feedback. Louder. Probably feedback. Sorry.
It's my role to pull things out. So I'm really feeling something, but I didn't expect that. Explain, will you be sure to, when you're finished, that they will have seen that you have pulsing magnetic fields, that they are not steady on, and that they pulse, one pole is going to pulse super fast, another pole is going to be slow, and what does that mean? Will you help us understand it? Well, I can't believe I'm feeling this.
Basically, all I can do is explain or show you what I've done. And as far as explaining it, it's unexplained to me. I'm really sorry about that. I'm kind of here like everybody else. I've noticed some anomalies. I wanted to share them, and hopefully we'll get some answers together. What I saw when I initially saw the videos, I saw a lot of people with a lot of very interesting things. To tell you the truth, at first I didn't believe any of it. And the thing that was jaw-dropping to me was the fact that Jamie had a little motor that he had made up similar to this one. And it was a little different, but it was
Gotta
just
keep
a little,
it by your mouth.
just a little wooden, frame. And I kind of threw this together the day before I got on the plane here. And I've been trying to get myself a digital commutator, but with no luck. I got some switches and some other things, but the switches were so small that they were affected probably as far as 2 feet away, so that was difficult. That wasn't going to work. So basically what I have kind of now is almost like a brushed commutator on it. So I'm not really going to, well, I can show it, but my discovery here was a solid-state centrifuge in playing around with the Rodin coil. The monopoles that I get are different than, or not monopoles, sorry, bias poles. Well, they could be mono or bias. One pole shows up, the other pole does not. I'm getting south poles. I've got them everywhere. I started playing with it, and it seems like everything that got touched by it was affected, including the permanent magnets that I had. So anyway, the first thing that I did want to go over with you was to show you the stratification. What I have here is a little carbon. It takes a while for this demonstration to work. So what I need to do is set it up, put it in the coil and let it run, and then I can go back to the monopoles and show you that. Okay? So,
No, you got to keep that mic.
well, I just need to,
Okay.
I need to load the hydrocell inside here. There's one that I call, one of them I'm calling a control, which basically I won't do anything to, and the other one is the one that I'll put in the coil. So both of them are the same, doesn't matter which one. I'll fill them up with this liquid. This was invented by a friend of mine.
What applications do they, there's physical centrifuges that are not solid state. What are they used for today?
Right now they're used for separating blood. They're used in the medical field. Chemistry for separating things, stratifying things according to density of material. So they're used in a lot of laboratories. Just about every laboratory has a centrifuge.
And how were you commissioned in the last month also to apply it to?
Oh, yes. Another interesting application came up, and that was for separating gold. And basically, I'd need a much bigger amplifier, but it did create some stratification in different minerals. Okay? That'd be better. Thank you. There's no clip on it. But
I'll hold this.
I'll go retrieve a clip, and if you can hold that for just a moment.
sure. Okay.
Thank you so much.
I'm going to have you read.
Locked and loaded.
All right, thank you. Okay, so what I'm going to do is load this up now with some HS. It's a
gave Peter the
silicon hydroxide solution. It has a specific gravity of 1.4. The graphite itself has a specific gravity of 3 to 4. And the product that I'm trying to retrieve from it is called graphene. And I don't know if many of you are familiar with graphene, but it's a new age superconductor, room temperature superconductor. It's being used in electronics, high-speed processors. I guess it's several times or several hundred times stronger than steel. But basically what I do is shake these up in the liquid, put that one in, and I'll fill up another one. Should have my glasses back on for this. A little background on me. I'm a systems integrator. I'm from Bakersfield, California. Lived a great deal of my time in Wisconsin, so this is extremely hot. I served in the military. I was on an icebreaker, so it seems like I went from extreme heat to extreme cold. I've been to the North Pole and the South Pole and just about every place in between. Let's see.
So I'm not sure if I heard you right. What caught your interest about the motor?
The big deal about motors, I've worked with a lot of motors, servo motors, intelligent motors, stepper motors, semi-intelligent motors, and just regular motors for turning fans, process control, and other things of the like. I attach drives to them and control systems, and basically I've never seen anything happen like that, and it was basically the most fascinating thing that I've ever seen was putting a motor under load and having the current go down. So I've been into...
Who demonstrated that?
And that was Jamie. And so far I believe he's the only one that I've seen. I think, no, that's right. Jorge and him both demonstrated that. But that, I haven't duplicated it yet, obviously. But everything else I've been pretty much able to duplicate the monopoles or bias poles and making the coils. I enjoy doing that. I'm coming up with some new designs on my own. I'm learning the math. It was difficult for me at first. I'm a patterns guy, so I look into patterns. And once I have the pattern, then I know it. It's simple. I see, I've been listening to some other speeches, and those speeches have basically verified what Marko's been saying about his math as well. There's just some key things, like having a symmetrical math that can describe asymmetry in nature. And there were several speakers in MPA that basically verified that over the last couple of days. Anyway, I'm gonna, let's see, here we go. I'm gonna put one of these in the coil and start it up. And then we'll try and hook up the other device and I'll show you
Show them what you've put it into.
in the other coil. Oh, yeah. I'm putting it into a coil here, driven by this little amplifier. And I'm using NCH tone generator. And I'm just going to start it now. It's running at 1.8 kilohertz. And that's the frequency that basically I looked up and found as being kind of a resonant frequency for graphite. Not graphene, but graphite. But anyway, I was hoping, in graphite, there's two bonds. There's a horizontal bond and there's a vertical bond. And the vertical bond is more easily broken than the horizontal bond. And basically that's been done through chemical etching processes. And I didn't want to go the chemical way. I desperately want to make the product because it's very valuable. And I wanted to bring the price down because there's a lot of people like me, a lot of other inventors out there that would love to get their hands on it and be able to do something with it. But at 10 times the price of gold, it's difficult. So anyway, a little bit goes a long ways. And this makes a little bit at a time, but like I said, it's extremely valuable. And there's so many things that we can do with it, from structural, electronics, talking about not wasting things. This stuff is pretty much indestructible, so when you make something out of it, it's pretty much going to last forever. So let's see.
Do you understand he's claiming that he's creating or separating strictly using
the coil and another product, the silicon hydrocell.
So the focused field, but it's also pulsing, is stratifying.
Yes.
Your.
And it could be because of the vortex action, and that's what I attributed it to. I was looking at the graphite that I had on the shelf. I was playing around with the coil, and I just thought, why don't I throw it inside there to see what happens? And if that field is actually spinning while it's pulsing, then maybe it'll affect it on a molecular level. So.
And what's the minimum, or give me a rough number of times you've duplicated this experiment?
About 4 times.
Okay.
Is that coil acting as a centrifuge?
Yes.
Thank you.
Pardon?
Is that really
It's not whirling, all it is pulsing. That's why I call it solid state.
You think you're making mono layers of graphene? You're taking one layer off at a time to separate it?
It would be considered multi-layer graphene.
I grew graphene years ago in Exxon.
Yeah,
Quantum graphite.
okay,
It's a mono layer.
all right,
You might be taking your graphite layers from the book and taking phase at a time.
right.
Then you end up with a solution that's specific to that place.
A solution, I would call it a solution of multi-layer graphene. And I know that doesn't sit well when I say that with some people, because a lot of people say graphene is only single layer. But all you have to do is go and try and look it up. It's on the internet everywhere. You can purchase multi-layer graphene. So, it's not something that I made up, and it's not something that I'm trying to, bowl somebody over with. So,
about how long will it take before you have your...
it takes about 5 minutes, and it should start stratifying.
Are you giving these away to the audience?
I've only got a couple of them left. I don't care if somebody wants them. But what I was going to do was show you, first of all, I'd like to show you about the coil. Now, that's not my coil, but I
John's
could
and Don's.
try it. I do have, I don't have it up here. I do have this one that I could possibly take out if I had a little screwdriver, and I could pulse this one to show the monopole or bias pole effect of the coil. Now, I don't know, there's a lot of people out here that have been using these coils, but one of the things that I've noticed with the coils, I'm pulsing it with DC, and if you measure it with one of these pole testers, no, don't cut it. It's too late.
Say that again?
Never mind. Okay. One of the things I noticed with the coil, it produces the same bias pole. So if I'm pulsing it with my tone generator and I put the pole tester by it, only one pole shows up. Now what I haven't been able to repeat here that I was able to do at home is get a bulbous protruding field. In other words, on one side of the coil, the field extended about 6 inches, and on the other side, basically, there was nothing. And when I tested it with the pole tester, I could test it, and I could see the south pole only. And then when I flipped it over to the opposite side connected, I had to actually stick this into the orifice. But since I've been here, I tried to repeat that. All I've been able to do is get the orifice on both sides showing up only as the south pole. But it still has pretty good torque on a motor. Now, since I don't have another power supply, we cut these. If you have your knife, basically what you might be able to do,
Scrape off
I need to scrape off, if we can scrape this off.
Here you go.
And then I can hook up straight DC and show them. Straight DC also works at showing the bias pole.
What are you plugging into?
Straight DC.
He's plugging into a laptop.
It's a laptop, an old laptop power supply.
Okay, an old laptop power supply. I
Yes.
was gonna say, if you want a powered amplifier, there's one there that has clip leads and everything already on it, and there's a signal generator connected to it.
Okay, well, I
But
just
it's
wanted to
right there
do,
if you want it.
I wanted to do the straight first, just to show.
This ought to
Okay,
probably get
so,
you.
so what did you do while I was sitting here? You took this magnet tester and you pushed the button down and nothing happened? Would you do it?
Right. What did you do with the little wire nut?
It's the orange and it's right next to the wood. No, all the way down.
Oh, okay, there we go.
Yeah.
Hold this for a second. I'll put these in series.
Okay. I heard you and Ernest discuss that you had different strengths and the magnetic field moved on the permanent
not giving
magnet,
anything?
semi-permanent magnet, based on the time of the day?
Yes. From about 6 or 7 o'clock in the morning till about noon.
So nothing.
pole seems to
John's
move.
hold that up for everybody to see. It's doing nothing. And the
This one has clear north and south poles, but this one, there's no, it's homopolar.
But does that one beep, the one you're holding, or no? It only does the light?
No, it doesn't go at all.
Oh, it does. How about on this one? Does
This,
it do
oh,
anything?
this one clearly has poles.
Oh, I don't hear it beeping.
We want the
Let
one
them
with
see
the
the
beep.
light.
That's right, okay.
Where's the beeper?
Yes, this one clearly has poles.
It's not
This
hooked up
one-
right now.
Demonstrates no polar activity at all.
It's not plugged in?
Do them together and try it.
What happened?
He just did it.
these
That's
two-
okay. No, that one. Now
see?
this one, now check the one you have in your hand. Check the
Now-
one you have in your hand, right there. Oops, there we go.
Okay? And the monkey pushes the button.
Now put the two of them together and see what the combination yields. Oh, yeah.
Oh,
What'd you get there?
Did you hear what Harvey said?
What's that?
Put them
two
together
meters to both of them.
and see how they work connected.
both are together.
Where's the other tester?
There's no yield,
No, don't
there's
know.
no yield to the combination at all.
We just had
You
two.
have them together?
Both of them are together.
We lost the
There's
beeping
no
tester.
yield on the
It's
combination at all.
probably back here. Want me to go look?
They're both
Yeah.
homopolar.
Okay.
Yeah, I'll hold
You got
on.
it? Okay.
I'm keeping your spot warm for,
Okay.
keeping his spot warm.
Theoretically, that's not possible. You have to have an electron flow coming from somewhere to go somewhere to be able to have
Okay.
an electron flow, right?
Okay.
Well, okay, here's the one that we tested. It's, and both of these show no polar persuasions at all. There's no polar persuasion on any of them. Okay, what was the question?
Right one in the tester first.
Oh, put this one in the Rodin coil and see if we get some activity out of it? Yeah.
Ah, there it is.
I'm only supposed to keep his spot warm. I'm not supposed to.
Here we go.
I'm not supposed to do anything. I'm just keeping it warm. There we go. Here he comes.
Just keeping the weapons warmed up.
Yeah.
So what I did is I put a little wire around mine, so
Okay,
basically
it has a
you don't
button
have
that
to.
pushes down.
You don't
and
have
he's
to press the
keeping it
button.
depressed now. So he's not, his hand's away from the button, which is good.
This is the beeper.
Right. Now here's the,
Hold it from the end.
this was
so-
used quite a bit, this magnet right here was used quite a bit in the, playing around with motors and playing around with the coils. And one of the interesting effects seemed to be that, I don't know if you can see how far away that is. Yeah, and then the north field. Right. And I'm not sure if all magnets are like that or if it's due to the fact that the coil has influenced it. But all I know is every place in my house now has got these bias poles. I've got scissors, I've got knives, all kinds of things everywhere. When they were saying they couldn't find them, I was finding them everywhere. I mean, it just seems like after I started.
Okay, so first test this and let's see there's nothing on it. Nothing, nothing, okay?
Maybe it's totally not magnetic. Maybe it's ceramic or glass.
What do you mean?
How do you know?
This right-
Is it metallic?
This right here? Yes, it's hardened steel.
How do you know?
This is a dowel pin. Here, you want to? Here. No, this is a dowel. You know what a hardened dowel pin is?
Okay, it looks real.
Okay, so we're,
Here's another one. Here's one with rust on it.
Harvey, that one belongs to you when he's done with it.
Yeah, glass doesn't rust, okay?
Well, okay.
Okay,
That's why.
Now, is this
which one is Harvey's when we're done?
Either one. He's got his choice.
Okay,
You see any poles there? No. No, I don't.
okay. Okay, so now we're going to create poles in them.
Okay.
well,
Shall I?
About the what?
It's still going. Has it been 5 minutes? Do we have 5 minutes? Okay. Okay. Let's take it out. Should have some starting of separation. I don't have much light. Uh-oh. Yep. Oops. Excuse me. Do we have a light? More light? Okay. I don't know if I'm getting separation yet. Is my coil going? Hang on a second. Now the coil is going. Okay. Can we see floating at the top there? The ring at the top?
Hold the light from the other side, see if that, yeah. And back up just a little bit.
Okay.
May I offer some assistance?
Sure.
Let's see if,
These by chance
see if
stainless
what we can
steel?
do here.
We'll have to ask.
Find the center of that. And
Is this stainless steel?
now,
No, it's not.
No, it's not.
No.
Okay.
you can barely see it, but there is some. Ah.
Was it Harvey? Here you go, Harvey. Harvey.
Yes,
Harvey, would you come around, not come up to the front? Would you walk all the way up, please?
come up.
By the way, everything that you're looking at right here, you can buy online on eBay or, you know, at the hardware store or at the auto parts
Same
store. Like the little amplifier he's using. This is all stuff you can do at home. This groundbreaking technology that you can take home and play with.
There you go. There's another one now.
Okay, Harvey, how many poles do you have on that?
Well, it shows none. My question is it stainless steel
No,
piles?
it's not.
Not stainless steel,
No, it's a hardened dowel pin.
hardened dowel pin.
So the
Okay.
pole
Bought
test,
from Granger's.
Yeah, and
This
stainless
is
steel
purchased from
doesn't rust.
Granger's.
Stainless steel doesn't rust also, so
Right.
that confirms that.
Right.
okay, wait. I'd like to see slowly. I'd like you to test, this is side A, and it has a pole. Now do side B, please.
Does this show a pole?
Well, it's
It's
beeping.
beeping at
Okay,
you.
it's beeping.
Here. Move your thumb a little bit. There you
Okay.
go. Now you can see the light. There you go. Pardon? On the south only.
Look,
Again.
can you get a north pole, please, Harvey?
Okay, apparently, south pole shows green, or maybe the both, but this shows nothing.
Here. Here's a
Now, here's a,
regular magnet.
Here's a
It's
regular
energized
magnet.
on these faces.
that shows red, which apparently means north. This shows green, which apparently means
Yeah,
south.
go down. Yeah, go down. Go down a little bit. There you go.
Oh, okay. That's kind of tricky.
Yeah. And
This is,
Okay,
I'm the kind of guy that
okay, now do the other one.
I'm not into parlor tricks, and a lot of the
Your
stuff you
choice.
see to me on the internet is parlor tricks. You know, lighting lights is, I don't know. I was doing that back in the 80s with just anything over 5,000 turns of wire pulsed. You know, so you can make any kind of coil,
called a monopole?
turn over 5,000 turns, pulse
Probably
it,
more correctly, it's
and
a
it'll light
bias pole.
lights.
It's an asymmetric magnetic field, meaning one pole is greatly more
You can
accentuated
have, you
than
can
the
have
other.
that if you'd like.
Will you show them now the frequency, the pulsing? Because that's, you have an application for that for generating power, I believe.
Question, do you think that since it shows one pole, that the flux lines don't go all the way down, so it doesn't show up? The flux lines might return in a very short path?
It could be.
Yeah.
I haven't thought about that, but
It
it's
could-
Just
it can
around,
be
just around
heavily
one
recessed.
inch. As a matter of fact, one of the things I noticed with some of the neo magnets is that in between the two poles, there seems to be, utilizing the magnet paper, there seems to be a white line. Now you get that white line, I notice, when you have multiple magnets stacked together. But it's almost as if there's multiple magnets in one magnet with the neos. So
from what you're saying, it sounds like the one end that shows a pole, it's like a thin disc magnet.
right. As a matter of fact,
And the one-
let me show you something. This is really interesting. Let's see. It's at this end right now,
Yes.
right? Let's see. Can I mark that? I don't know if I can mark it with this.
trying.
Anybody have a marker? Do you have a marker?
Yes, I do. Right.
Magic marker? Something that won't rub off? Well, one
Mikey,
end
magic
is
marker.
curved, the
To
other
right.
end is flat.
Okay.
Right? Okay, basically, oops, we're off.
Yeah.
Okay, I want to mark this end because this is where the pole. Okay.
Okay, now, okay, the black side shows,
Here we go. Oops, our button came loose. Okay, that's the one that shows it. That side doesn't.
the black side shows a pole.
Right. Now, let's see this guy here. Okay.
You reversed it? Wait a minute, which is, okay, the black side, you reversed it?
Right.
Is that magic?
No.
Wait a minute, whoops, this,
Oh, yeah, if that slips off, it won't do anything.
okay. Okay, whatever he did, it put the single pole on the other end of the magnet. I'm sure that,
It's not magic.
I'm sure that after studying it, you know, we'd figure out exactly how it's happening.
Right.
And on the, a
Basically,
quick
that's what
thought,
we're at for
it looks
rough
like
answers.
it turns well, I'd like to see that happen to a bar that shows poles at both ends,
Mm-hmm.
and then switch it to one that shows only one end, and the other end is as if it's a very thin disc magnet,
Right.
with you able to access only the one pole. The other pole is hidden inside. And
Right.
I'm guessing that, I'm an electrical engineer and I
Whoa.
played with magnets, and I'm guessing that's how it would be.
That one's huge.
What are you doing, John?
You have a question?
A mess.
Harvey,
Yeah?
I'm going to have you sit down here for a second.
The monopole or the bias pole? No, I hadn't. No, I hadn't. One of the other interesting,
This is going to be very interesting now. Are you going to show the pulsing frequency?
yeah, that's what I wanted to do.
Okay, maybe we'll do it
Well,
in
first of
front
all,
Harvey.
let me show the DC direct current. If I can get that on here.
Okay, let's do it on top of something, so let's use this.
Now we're not. Okay. This is with direct current. Now, that's another interesting effect to me, is this pulsing.
Describe it in words. What is happening?
What's happening here is, well, as you can see, nothing this way, something that way. So I believe that this has been the major influence, maybe not, but I'd never made those observations before. I've never seen them, never heard anyone talk of those observations before.
I would say that this phenomena is much harder to explain than this phenomena.
Okay?
Yeah, but of
And-
course, both.
And you've been an
both
engineer
sides,
for how many years? And you've never seen
over
it?
35 years, and I've never seen anything like that.
And what is it that you're
Over
describing
35
that you
years,
haven't
and I've
seen?
never seen a motor current go down either,
You've never seen a field only on one side.
only on one side. Okay.
Anybody, just yell out.
What would you expect to see? And then what is the potential of a monopole?
Okay.
Do it again.
Okay.
I don't know if you can see that. See it swing with the foil?
It's just following it around. So it's the same both ways. It's,
Do that again. If that really matters, let's see it.
well, yeah, I mean, it should flip around, but instead it's following it. See the same pole? Yeah. You see how it's following it?
And it's not following it
It's-
pole to pole, it's following it from the side.
Okay, let's do it for Harvey. Bring it over here, please.
I don't know, you...
Son of Harvey.
Okay.
I've seen it.
Okay.
I don't know if you could see it, but the compass that he provided there was not following it north to north or north to south or south to the, it was following it from the side.
There's
It
more.
wouldn't,
You're gonna
it
like the
wouldn't
next.
select either north or south.
Yeah, because you're going to have something more.
Yeah, it's a interesting, strange phenomena. A lot of really interesting things about it.
just
And
want you
another
to rest.
characteristic about it
I
is
just
all
want
you
you to
know,
rest.
there seems to be a great deal of current inside the coil. And that's another thing, of course, I've been trying to figure out a way to get out of it.
What are the various variables that affects change on that thing?
I wouldn't have a clue yet.
What are the various variables that affects change?
It's difficult. I've only been at this, like I said, for about 3 months. And most of it has been running around lately and not experimenting. So it's really hard to tell you.
How would you
I
get
don't-
electricity out of it? You've just said that you would like to get the
May I
energy
offer
out
a
of it.
comment on that one?
Sure.
The amount of poles that you use when you select the winding, the amount of points on the poles, that affects the frequency. The amount of reps affects the amplitude or the current, and the force with which it pulls. The strength here is, strangely enough, there's a point with which you can put more reps on it, and it doesn't increase the strength. And there are coils over there that you can look at, that some of them have 5 reps, 10 reps, 20 reps, and 30 reps, but the coil has the same amount of poles, the same amount of points, and the same advance, but there's just more reps. And we've tested that, and we found that there's a place where there's an optimum number of reps that it performs at, and it finds a harmonic balance, and it's when the signal is passing through it, and we've experimented with square wave and regular sine wave and sawtooth waves. We've actually experimented with a few arbitrary waves that we've built into the signal generator that you can program. We found that when you use an AC current, it passes through this conductor and goes around and comes through this edge and back through there. We'll see that follows up, but there's a point with which the frequency that you're putting into there, all those coils line up in perfect symmetry, and the strength and the amplitude of the pulse as it's passing through it, that is what gives you the symmetry. When all that coil, when all that wire is tuned to the right dimension and diameter, so that the sine wave is the same in each of the adjacent coils at the same time, that becomes incredibly strong. And the frequency, because it travels through there so fast, the frequency that you have to use to get that sometimes is a little perplexing. But we have 2 coils over there that we call the Magic Coils, or that for some reason we put very little current into them, and the strength and the effect that they affect, like a diametrically polarized magnet like these, is just unbelievable. And we measure the current coming out of that amplifier, and it's almost nothing.
One of the things that I was just starting to get curious about is the size of the aperture. All of these pretty much have about the same size, but changing the angle will affect the size of the aperture within the toroid. And so one of my next ventures was going to be to cut a larger opening in the aperture and reduce the slope, or increase the slope angle, and then also squeeze it in smaller and see if that affects the magnetic field. There seems to be a whole new series of principles when it comes to this coil that no one's really explored. Now, yeah, these are some that hug the toroid a little tighter. Let's see, we did try one that was kind of cross, but didn't seem to have too strong a feel. Now,
This one's a 5-2. It advances 2 every, and it's 5 pole, and that is a 411. It's 11 poles, and it advances 4 poles every time, so that the wraps, and that looks like a 11P420 is what that is.
Willie, when you said you'd like to increase the aperture, do you mean starting with the toroid with the larger hole in it?
yes. In other words, if I took the toroid here and cut the center out of it,
Well,
to make a larger,
That's a hollow air core
right.
toroid.
Right.
Now, wouldn't you achieve that
Well, that
by selecting a toroid with the larger?
Well, yeah, if I can get it thinner,
Like a hula hoop.
More like a hula hoop,
Yeah.
but not as big as a hula hoop.
I've
Small
noticed
like
that
this.
Most of these toruses or toroids, they're sort of all proportional, sort of.
Right.
That hole is sort of related
Well,
to the
No,
diameter.
now these wraps, they look beautiful, are quite a bit different than these wraps. These wraps, I don't know if you can tell or if you can see, but there is kind of an opening in between the toroid and where the coil starts to fold over on itself. Right, like this one. See? Yeah, that's what I was going to start playing with next. Now, have you noticed any difference in the field strength? Quite a bit more, quite a bit less, quite a bit more. Huh? Less? Higher, higher, higher? Really? That's what I was thinking. Okay, yeah, that's what I was thinking would happen. But I'm really new. A lot of you guys have been here a lot. My first time.
Hi. Have you ever thought about putting water or structured water in that, and then perhaps shining a laser light that is tunable, like a tunable laser dial?
No, but it sounds like a great idea for an experiment. There are so many things I would love to do. Unfortunately, it takes a little bit more capital than what I have, as you can tell. So, I mean, there are quite a few ideas that I have. But the first thing I would like to do, of course, or what I approached Marko about, was trying to pull people back together, because there's a lot of really interesting things that people have come up with already. And I wanted to try and take all of those, being a systems integrator, I like taking goodies and putting them together and making them work. So that was kind of like the first idea I wanted to do, because it seems like every time somebody gets something that works, they go off into their own little corner and they're doing their own little thing. And to me, if everybody's pulling in the same direction, you know, to move something, I don't know, you can get off center and you can make things happen.
I have a real wild idea. Hand me one of those toroids, please.
Sure.
Suppose you put a fluid inside of here, maybe not water, maybe I'll call it a magnetic suspension fluid. And the goal would be to attempt to somehow get that fluid to circulate. Now, I'm an expert on angular momentum and moments of inertia. Now, this is easy to turn, but if it was spinning like a gyro, you have a hard time turning it, see, and it'd be a super goal to turn this thing, which weighs, but easy to rotate, and get it spinning inside so it's,
You want the mic again?
turns it into a gyro. Now that would be a real trick,
Okay.
and try it with fluid inside at some time.
Right, right. I don't know how many of you might be familiar with MHD. You've heard of MHD? Right, Magneto Hydrodynamics. And basically that's where you're taking a gas, a fluidized gas, that has particles in it, and when you move it to subsonic speeds, it creates current in a coil around it. So being that these are multi-coils, basically you could have even another coil around these, but if you're pulsing them and you get that, like he says, you get that fluid moving, it would be hard to move, but also if it's going fast enough, if the fluid is moving fast enough, then of course, oh, here we go.
Just any
There we go.
ionized water will act as a magnetohydrodynamic fluid.
Really?
Yeah,
Okay.
just
I thought you needed bromine and
yeah,
other.
I just want to add to Harvey's statement. Just put some water in there and then put a little styrofoam, something that floats, so you can see when it's turning or not.
Yeah, that's interesting.
Say it again?
Little styrofoam.
Okay, just do what Harvey's. I'm just adding to what Harvey is saying. Just put water in there. Don't fill all the way up, but then add a little piece of styrofoam and see whether or not you get any circulation.
Okay.
May I speak to that?
Sure.
We have chambers, we have glass, we've got tubes that we fill with water. Some of them deionized water, some of them that we put a little bit of dye in, that we put the coils around. We use regular Erlenmeyer flasks and just regular barrettes that you lower it around. And certain coils, that one right there, this is a non-ferromagnetic holding fixture that we can use to rotate it also to create a 3-axis rotating field. That's part of what that's for. By the way, see that? Yeah, that's machined. It was done on a mill, you know, it's CNC, the whole thing. But look at that. You can do that at home. This is something you can do everywhere. But we've found that you can. Back in 1978, 79, I worked on a project with Lockheed, Magneto Hydrodynamic drive, USS Nightingale. I was loaned out for a little bit on it. You know, you saw the movie Red October, you know, the Caterpillar drive, there's something wrong with it that could be the superconductor. Well, some of these coils, we've induced a vortex in regular water that has had chlorine in it and salts in it. We've induced a vortex and a flow in deionized water. That's a toughie without electrolyte. Most people say it's not possible, but everybody, when they start down that road, they forget that water is a polar molecule.
Well, there's that. I'm interested because, you know, water in any kind of surface, you have that exclusion zone. You got that proton wire that's right outside the exclusion zone,
Right.
and that's superconductive.
Right.
And that's called proton jump conduction.
Say your name out loud.
We had another, go ahead.
Your name?
Well, did you have another one or?
No.
Okay.
I'd like him to do another experiment at this moment, because I think you'll also have more questions for the next experiment. It's hard to see. I wish we had a ruler, but we can use anything. Willie, you know where I'm leading?
Yeah.
He has a tape measure, a ruler.
Let's
Do you have a
see.
tape
I
measure?
believe in my,
What was the question?
maybe not.
Get your
Graph
tape
paper.
measure.
We're about to do a second or a third experiment, and it's going to.
Right. He just
It's gonna
wanted to
be
show
bizarre.
that distance thing again.
While we're waiting for the setup, let me just ask, it seems like a lot of the focus is on the number of wraps and the number of layers of wraps and that sort of thing. What about the possibility of thinking in terms of resonant tuning with a length of wire? You can control that perhaps by the diameter of your donut so that the wire is tuned to a specific
There's a lot of
resonance
different,
tuned
there's a lot of
into
different
what your
ways to go
target
with
is.
it. And
Willie's.
because when I
And-
first started looking at it, I realized there were so many different ways to make the coil, and it looked daunting making the coil in the first place. So what I did, I don't know if you guys can see this. Oops, what do we have? I just lost my screen. Did I? Have I been unplugged? Do I not have power?
You have power.
Okay. Okay.
Okay.
Fumble fingers.
I asked for Harvey to stay here because, Harvey, I'm going to ask you to verify the difference of the pulse rate of the different poles. You'll see shortly, as soon as Willie does it.
Oh, here we go. Anyway, I just wanted to show them what, one of my first things I did was design, I don't know if you can see it very well there, but I designed myself a coil winder. Because there's so many variations, and since I'm a PLC programmer as well, I thought I could put stepper motors on it, and I can program the moves, and I could automatically wind coils. Basically, the way this thing works, it's got two X's that go into the center. So basically, you have a robot, or not a robot, a pick-and-place type arm that takes the coil out, puts it back in, it goes across, and the coil steps with a stepper motor, say to a certain amount of degrees, depending on the number of spires that you have. But with the 12 spires, I think it was 10 degrees each move. So it moves 10 degrees, and then it goes down through, comes back, then it moves 10 degrees, it goes down, comes back, moves 10 degrees. So I try to create an automated system, something to be done in the future, because there are just so many possibilities and so many variables. It would take a room full of people like this to start making coils.
Did you finish,
You know, by
did you build one like that?
No, I haven't.
Okay.
I'm actually in the process. I've got a 3D printer that I'm working on.
Okay.
And
Okay.
anyway,
Well, that was
hopefully.
just food for thought for tuning to a specific substance
Oh, yeah.
with the length
That-
in an antenna
definitely,
format,
Definitely,
and then making a coil to
Right, right.
intensify it.
right.
Okay. Would
It's-
you-
it's just
Would you
remind me of
demonstrate,
something.
Willie, would you demonstrate the pulse?
Oh, yeah. The difference, you had another question, or, okay. Let's see, why don't we start at this end here and we see how far we go. And if we do it with, we was doing this with regular magnets, not monopole, but you can see how far away.
Well, if you center it on the center, it doesn't matter. You don't have to be at the end.
Okay.
Yeah. Okay. So,
You just wanted to get a measurement for how far away it started affecting it?
and then I want to see the frequency.
Okay, so it starts about there. Now, this, to me, everybody ignores this pulse. But this is one of the most fascinating things about it.
The audience.
It's one of the most fascinating things about this is that persistent pulse.
You can't see it on video. You can't, yeah.
Okay. Well, you're not going to see the tape measure, but anyway, here. Can you see my hands? Where am I?
And say, Willie, just you
Okay.
eye it. Tell them how far away it is.
Okay. And we're about 3/8 of an inch right there. A little bit over a quarter of an inch.
And what would you call that frequency? Let's just give it a number. Call it a...
2 or 3 times a second.
Okay. Let's
Okay,
do the
about-
other side
I
now.
was just going to say about 5 hertz or so. Basically, we don't have anything where I can touch it.
Right.
Now, one of the other interesting effects, like I said, was, what did I do with that other? Yes, that was the Dow. That was
It's pulsing.
it's
It's
pulsing.
giving off
It's a persistent
repeating
pulse.
signal.
That was to me, that was the most interesting part. And the second most interesting part of it is when I pulse a coil.
Could I have that mic?
In pulsing a coil,
Hold it.
okay, we got better stuff. Oh yeah, that's looking a lot nicer. I don't know if you can see that. Can you see that? It's starting to look a lot nicer. I don't know if you can tell or not. My hand is so dark, it's kind of like covering it, but at least from the way I look at it, but better stratification there. But it should be consistent, right? And the thing that's really fascinating is that the higher frequencies, you should, right. Right. At the higher frequencies, you should have a steady hum. And rather than a steady hum, I'm getting what appears to be almost like a Morse code coming out of the coil. And it just seems very odd that the magnetic field is producing a odd pattern versus a pattern that's being pulsed into it. The pattern that's being pulsed into it is a constant frequency. It's steady, it's even, and it should just be a buzz or a hum. But rather than being a buzz or a hum, it's getting these pulsing. And that seems very interesting effect. I don't know if it's...
Standard magnet. This is neodymium. Belongs to John. It's steady. Both sides, steady.
Yes.
Okay? Now I'm going to do standard neodymium magnet.
okay.
Agreed? Now, the biased magnetic field magnet.
Match 'em.
That is interesting. That's interesting. Yeah. That's about 5 beats per second.
Eric, what do you think's going on?
I don't know.
Leon. Speak real loud, though. What do you think's going on?
We've made cymatic devices in Ashland out of Rodin coils, and it gets me away from moving the water just in one line. We're actually floating the water in the field. And
Where'd my other one go?
when we
Here, and hand it to... Yeah, go ahead, you're done.
we've been seeing all kinds of effects in Ashland. We've got a couple of members of the Rodent coil crew up there, and we've made cymatic devices. We've been working on the speaker aspects of the Rodent coils, and we've had some of your monopole magnets there to test, and I can't explain it. I've been playing with magnets. The Simoscope is held together with neo-magnets, and I've been using them for years in design. And to think of the implications of what you can do with magnets, that you can actually, there are programmable neo-magnets now that are very expensive, that you can vary the gap and the reaction of the magnet. But if you can actually program magnets like this, you can get a lot more useful applications out of it. I don't know exactly why it's happening. I don't know. I wish somebody in the room could explain it to us.
So I believe that magnetic fields are also standing waves of Tesla type, and they also have harmonics. So when you say that you noticed a few, or you think that there are like several magnets in one, it's really a harmonic of the standing wave, which usually has a north and a south.
Not that one.
Now, what I think it happens here, that it's no longer a static magnetic field, but it's a standing wave which rotates, so like a Lissajous figure. So it gives a different beat because it's like a superposition of fundamentals, of beats.
Okay. I'm
So
just trying
that's
to add different variables. So I have two different ones now. Right, Willie?
Yes.
Are they going to have different frequencies of pulse? Why don't you hold,
That, I don't know.
Sure.
Okay, stand right here, please. You hold the first one. Don't let it touch your ring, though. Got it? Okay. Right here, to the audience. Okay, it's... Okay, I'm holding my finger down on it. Nothing. No? And nothing. Okay, again. Almost has a personality that you can distinguish with the pulse. Okay? I can't hear you. This is the other one now. Come on up. Nothing on this side? Sounds about the same. Maybe this one's a little slower. Go ahead. Just hold down the button. What's interesting to me is no one's ever seen this effect before.
That's not true.
Then I'd like to know where.
Now, Marko, take the mic. Where's that other magnet at?
Eric has it.
Get that other magnet. No, sir, come here.
I have to go to the restroom.
Okay, all right.
Okay, I want you to
All right.
hold this end
I'll let him
of
know.
this magnet. Okay.
Oh, we can break the microphone, so we gotta keep it away.
This one wasn't doing that before, was it?
Yeah, they both are.
Yeah, if you notice, it seems to speed up the
Okay.
closer you get.
So,
It's a variable magnet.
Yeah.
This
I'm gonna hand you the microphone.
It's picking up energy from the field.
And did you want to put them together, Harvey?
Yeah, yeah. But with that in mind,
yes, you're right about that.
pardon?
On that, it's a slow enough frequency that the compass should be able to react to.
What do you mean?
It should be able to like turn or vibrate.
On there? Oh, yeah, sure.
It's a phi ratio 1.6.
Phi ratio?
Collapses 1.6.
Static magnet.
Okay.
Or some
There you go, right there.
Exactly. No, Willie does have it.
I
here it
never
goes.
tried to measure that.
Here goes
As you can see, there's a
compass.
great deal of better equipment that's needed to, to do more experiments with this. It would be nice to have a website so that everybody could kind of get together and see what we're all doing. And
that is the next platonic solid shape.
right, you know what?
Collapses 1.6 or collapses at a ratio based on the next platonic shape. It's collapsing.
All right.
Okay.
Don't know that for sure, but I'd like to know.
Give a possible explanation of what's happening here. If those of you who are familiar with John Searle's work, he was able to program magnets with a sinusoidal pole pattern on the magnets.
Okay.
You can order magnets with multiple poles on one side. But what I think is happening here is on the side where you're not detecting a pole, it could be the case that you've got many small, multiple poles, both north and south, on the same end. You may get both north and south poles on the same end of the rod, such that your detector doesn't detect them because they're smaller, and they're canceling each other out basically if you're not getting the detector close enough. Also, you could be getting weird pole patterns because of how the electrons move and accelerate through the coil. You could be getting strange patterns of poles that are asymmetric and multiple poles and so forth.
Right.
What's your name?
I understand what you're saying.
My name is Randy Wood.
Randy?
Okay.
I'm gonna comment on your comment. I'm gonna discuss multiple poles. Go ahead and sit there. What he said? Randy is the one who said that, I'm reiterating what he said, that there's multiple poles, he thinks, but the nature of how the current's going through the conductor, in this case the copper on the coil, but I'm going to address that in maybe 20 minutes or so. Because of course that's very significant. Okay, where are we at?
You're on stage and I'm on the floor.
Let's look at the centrifugal again.
Yeah.
So Willie, thank you.
Basically, you can see a distinct layer at the top now. Let's see, do I need to have the light again, or can you zoom in on that? Is it?
This is the control. Maybe.
Yeah, that's the control. Here, let's hold them side by side.
It's very hard.
How many grams is that?
That's the control.
See if we can figure out a way to light that satisfactorily so you can see what's happening.
Can you just pass it around?
Sure. Yeah, here, just pass it around.
Here.
Okay. Yeah, let's just pass it around so they can see them.
Yeah, that's probably the
Just
best
keep
thing.
them together.
Show and tell, pass it around.
I'll give you the mic as soon as we're done.
Keep them together right there.
Will you grab that mic? Harvey has an observation.
Okay. There you go.
I went to the thinking stool for a minute. And with regard to the beeping, I'm almost certain that that's an interaction between the steady-state magnet and the sensor. When they get close enough, there's enough of an interaction to light up the bulb and cause it to beep.
You're saying it could be the circuit in the detector.
It's an interaction between the magnet and the sensor. Once the sensor senses it, that changes very slightly the strength of that magnetic field there, because it's sucked up into the sensor, and then it shuts off for a second, and it just oscillates. And the closer you get, the more rapidly it beeps. And one other observation that I have, I mentioned about, could you get a fluid circulating in there? Let's say you have an ionized thing, and the number of wraps around it, let's say you pulse it, and you pulse it here and here and here and here and here, you could get it moving, you could get circulating at thousands revolutions per second if you pulse it right. And I'm almost certain that that could be done. You'd have to figure out the windings and all that kind of stuff, but then you would have a variable magnet for whatever purposes. There could be a lot of applications for something like that, but I'm certain you could get a rotating fluid inside of a torus, inside of a Rodin coil, and then figure out all the applications for it.
Okay. Willie, what are you doing?
Well, what I wanted to show was the...
Thank you, Harvey.
Yes, you're welcome.
What I wanted to show was the effects of a pulsing coil and then the pulse in here.
Sure.
They don't match. So if if what you're saying was true, it should kind of follow the frequency. As the frequency collapses, right, you're going to hit that same sweet spot, so it should pulse evenly, just like the varying frequency that you're putting into it. But what I found is that when you're pulsing the coil at a steady state frequency, you get a variable pulse. It almost sounds like a Morse code. And it has these patterns that repeat. I don't know, if anybody's ever just turned theirs on like this and just put it in there and left it on, and I just kind of like bounce through the frequencies.
Are you going to demonstrate that variable?
That's what I was just going to try to do.
Okay. And where is it coming from? Is it an intelligence in the magnetic field or the flux? I like to be an
Pose
advocate.
those questions?
Yeah.
Let's see. Let me make sure that might.
Is there an intelligence in the flux or the field?
The pulsing, is that a
Very dangerous.
Okay. I got it.
the pulsing, is that a steady state pulse train?
No.
Or is it an irregular one?
It's irregular. Like I said, it's more like Morse code.
Come on over here. See what he's doing.
I have a comment on that also.
Whoa.
You hear that? Can you guys hear that?
The mic isn't on.
Is it the ETs communicating to us?
Yeah. Is it? Okay, now that's at 46 hertz.
Can you hear that?
You hear the regularity of the pattern?
The pulsing is at 46 hertz?
That's, right, it's being pulsed at 46 hertz.
There's a double beat or something?
Right, steady state pulse. That's a sine wave. Yeah.
Match it up and you can make it up to a cross-current transform and see whether it's just a multi-phase system with interference.
He says a multi-phase system with interference?
Well,
Those are different frequencies I just shifted.
No, I'm not saying I'm familiar with any of this. I'm just
could
trying
be
to give you the best demonstration
These
of the
are
principle.
just observations that I've made. That's what I saw on YouTube, everybody making their
Let
observations
out.
and
Just yell,
sharing
come
them.
on up. Who is this?
What if you put a coil on the magnet, monopole magnet?
Pardon?
What if you put a coil on the monopole magnet?
Internal or what?
No,
Or around
outside.
it?
So
Around the
on the
magnet?
side that is changing the magnetic field, so it might generate an electric current. on the
You're
coil.
saying it could be a dynamo.
Yeah. Right, that's basically what I'm going to do with this little model here. It's a rough.
He's saying that you can actually make it a power
Right.
generator.
Right, that's what I'm going to do. Basically what I'm going to do is I'm going to take what Jamie's done and some of what the other people have done and incorporate them. Like there's the accelerated regenerative systems out there right now.
Did you see that?
As long as I make enough changes, I'm cool with it. And then of course what Jamie got, he gave me permission already to use that. Basically, so if I'm loading the motor with a generator, you start loading it, I should lose power. And if I have regenerative acceleration, if I kick that in when it starts reducing current, then basically it'll speed it back up. So with the aid of a PLC, which I program them all the time and I'm into automation, I should be able to create a cohesive system. What I would really like to see myself is I'd like to see next year at this time, I'd be able to pull up with a trailer and we could disconnect power here at the hotel and run off of a system created utilizing the Rodin coils. And I think we can do it. We can put up a website and we can work together on it. And everybody should be able to benefit from it.
I have a comment on this. When it sounds like Morse code, beep, 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 beep.
Right.
It could be a modulation effects. Depending on the windings, it's a steady state pulse train, but the windings, it's hard to predict.
Right. It's hard to predict
sometimes
what
you
it
have
is.
sometimes you have to measure what the response is.
Right.
And there could be a modulation effect there.
Willie, are
It
those your
doesn't show
glasses? Are those your glasses?
Yeah, it doesn't show up in the oscilloscope, but I believe that with the right test equipment, we could locate and find out what it is. Because occasionally, while I'm listening to that pattern, it does change. I mean, it goes for a while, and maybe 5 minutes later or 2 minutes later, it'll change to a different pattern. Or it'll change to an irregular pattern and then go back to a steady state pattern without me touching it. And it could be transients, it could be transients in electricity, you know, coming from other equipment. I don't know, but it's really interesting and
I'd like to contribute
it bears
something, but I
investigation.
can't say it in the proper language, but I'll try. In the 90s, in fact, Al Henderson of Signature Antennas, the military had a competition, and using my coil, he won. And the reason he won is because these coils, I'm going to go more into it, but I don't know if, I don't have any animations to explain it well. They don't have, all coils have a certain, what is it?
Attenuation.
The audience knows antennas better than me. They have a certain impedance, they hit a certain resonant frequency, by the very nature of their existence, how they're made. Okay, but see, this is kind of an optical illusion. Some of you are familiar how it's made, but most of you I don't think do know how it's made. This is actually, I'm not going to go into the bifilar pair, and I'm not going to go into the gap space. I'm only going into why the impedance has changed in this coil and why it has a much greater frequency and range. Actually, the people who've done the experiments say it's ad infinitum. And here's why. Because on the axis, this is wound such that if I start here with this wrap, the next wrap, after the fourth wrap, I'm passing this wrap at a right angle, and I'm coming over here before I ever lay my winding or my wrap on each side of the one where I began. That's called a spire. Does anyone follow what I'm saying when I'm talking in spires? Okay.
Right angles are create the greatest spin.
Well, there is an energy that I'm tapping into, and I'm not even going to go there. And the principles of spin. You know, they've had a sphere. A lot of you have seen. The fastest they've got it is close to 500,000 RPM using this coil. I could show a video right now, but I'm just going to stay on the spires. So it's actually inverting. It's actually, and I'm trying to use the subatomic particles of motion, the energy, to gear in teeth like gears. So I'm just going to see if, I don't know if I can, but I'm going to try and track this to show that this is passes itself at a right angle. So one, okay, so I'm coming here. John, did you make this? One, I come out here, I'm going around here, so this is the second turn. First turn, second turn, the third turn is going to be right here. There's the third turn, and look at that. And there's the fourth, which is a right angle to the first. Did you follow that? Yeah. And that's deliberate. Okay? And when Willie's done, I'm going to explain. So it went around fourth. I'll continue it. Fourth.
I think I've got a better way. Hang on a
Okay.
second.
Well, I'll just finish the winding though. Fifth. Sixth. Seventh. Did I miss it? I think it's well, it's going to be many times before this ever wraps are ever side by side to where it began, which would have normally have been the last wrap, the first one, or the last one for that wrap. Does everyone follow me? A conventional coil, so many turns, so many wraps next to each other. And instead, I'm doing a Chinese finger pull in this winding. Do you follow what I'm saying? It's a what?
Double loop system.
It's a double loop system? Where do you coin that term from? And, take the mic, if you want.
Let me just say something.
If you're helping.
Real quick, let me say something.
Go ahead.
This is how I explained it to somebody to wrap it. I don't know where I got it from, but it came to me from the drawing that I did for the basically the coil winder. And it made it easier for me to wrap it. If you start at a location like we're starting here, and you count 5 turns, and you go 1, 2, 3, 4, 5. You go 1, 2, 3, 4, 5. And basically you bring this to this fifth one, and you go 1, 2, 3, 4, 5. You end up over here. You bring it to this one. You go 1, 2, 3, 4, 5. See, it never ends up. It goes all the way through those iterations until finally you end up back at the original spot. So, you know, to follow it, you can just keep going that way. One, well, let's see, I go on this side. Let's see, where do we go? 1, 2, 3, 4, 5. And then you'd wrap on that. 1, 2, 3, 4, 5. You'd wrap on that.
And by winding it in this way, everything's focused on the axis.
1, 2, 3,
Here,
4,
all the
5.
windings.
Wrap on that, see? And each progression, it shifts. But just by that 5 count, it made it really easy. I had a guy in 15 minutes made a coil in an hour, and it took me days to be able to make one. But just explaining that little trick right there, you know, the 5-step, and that's what the 12 spires, if you have the 12 spires. So, and I'm working out all of that for the other math. But I see patterns. So patterns is what, you know.
Is there a video to watch?
You can watch a lot of them. I watched, I think, just about every one of them. And nobody explains it that simply.
Okay. Willie, please keep me company if you want. I'm going to do a PowerPoint presentation.
Okay.
Will you explain while we're starting that it's bifiliar and there's actually 3 parts because the gap space is critical?
Right.
Now, Randy, you spoke about multiple poles. So the purpose of this coil is actually to create eddy currents. I use my own term. I call it underpinning nested vortices. And so if the math was properly explained by me, which I'm not going to try,
Shall I go back down now?
if you want. But thank you for sharing.
You're welcome.
Thank you. Thank you. Oops.
Now, ladies and gentlemen, while we're getting ready for the PowerPoint and the videos, for the unchurched out there, there will be a clinic after the social. So if you want to go grab a veggie wrap or a ham and salami or something and a bag of chips and come on back, after we get done here, after Marko and his whole crew get done, and we got to go out and get something to eat because the social, actually the food's already out there.
So is the food already out there? Is it time to eat right now?
Actually, it is.
Right, that's what I thought.
But, you know, I asked Steve if he could slow down the second wave of food for us.
But I don't have to start this minute. And what I'm about to start on is the mathematics, and it gets really complicated. So I'd rather I don't mind if whoever wants to come back comes back and whoever doesn't does not. So I'm willing to resume after if there's food, and everyone better eat.
Well, okay. Well, let me ask you a question. What would you guys like to do? We could let them run a little bit, maybe quick run through the PowerPoint, and then save everything else. Stop right there, and then we could go out, get some groceries, come back and throw them down our necks here, or
I can rip through the PowerPoint.
Or we could do the social.
I can say I can do the PowerPoint in under 5 minutes, but it's not going to be. It doesn't matter because I never was going to explain anyway.
And then maybe go get something to eat, and then we'll come back.
But I had 2 other presentations, so when you come back, and they're significant because everybody's making Rodin coils, and they are using a schematic and a pattern that originally came out of a book I wrote. And the next generation of Rodin coils, I'm going to give a schematic right now that it should be endlessly more powerful because I'm going to explain how to ramp up the principle.
We're learning how to tune them.
Yeah. Okay, here's the PowerPoint. This was done, and my God, I'm not going to try and explain anything. But that's the base 10 system. It looks like a circle. 360 divided by 40 equals 9. The 3 and 6 end in the middle of nowhere. I actually model magnetism with the 3 and 6. It's a higher dimensional gap space. It's really, you leave it alone. That's the gap, the big spaces in the coils here. And I'm going to be quick. I'm going to try and just finish up so everyone can eat. And then I'll resume on other discoveries and applications by other people. This discovery I'm about to go into is by Russell Blake from Microsoft. There isn't a PC made that doesn't have his software in it today. So the 9 is very significant. It's the control of the 3 and 6. When 9's negative, 3 and 6 are positive. Essentially, that's the binary code, 1, 2, 4, 8, 7, 5. And it turns out that the binary code, I say things that are incredulous. The binary code is not binary. No, I don't have it turning on. The binary code is triangulated. Triangulated. It goes over, you agree. Because for every binary code, you have to have a second binary code.
Okay. Where did it go? Oh, it's back here. Here we go. Oh,
Thank you.
okay. You got it. It's on.
Here, where's the mic at? I'd rather you say it so everyone can hear it. Where's the mic? Who's got the mic?
Check.
Here's one
Right
that you
here.
can press.
I like this one. That's
Okay,
fine.
that's good.
Anyway, so that's the source right there, and there's an emanation coming out of it linearly, and it's actually, this is a language that is so incomprehensible, and it took 23 years for me to assemble a team of people to figure out how to apply it. We'll just move on. My best student in computer science, so this was an endorsement of my work, and I just liked it, and it's going to take a minute to read it. Maybe I'll skip it and we can read it later. But it was by this is the German Journal of Oncology asking to publish my work on DNA, because I'm showing that the phosphates create a higher dimensional flux field because the phosphates are always known to have a negative charge, and phosphates make the DNA backbone. And so that major groove of DNA, if you Google major groove of DNA, you'll see it's the space in between the helixes, has a flux field. It's called the biotheric template, morphogenic field. Essentially, there's an all-coherent intelligence guiding evolution. I'll just keep going. I'm glad I have to do this short. So next slide, please. This is where I published my findings on DNA. It's called intelligent design. And I'm saying that evolution is based that it's taught in school with Darwinism is wrong. That there is no random chance in evolution. And I'm showing that all the information of evolution is preserved in higher dimensional flux fields, same as these coils. Okay, we'll keep going. This was by Tom Bearden. The reason I picked this endorsement of my work, let's go to the next page of it, is because Tom received the Sagnac Award at the MPA, and we all love and respect Tom. It sure is blurry. There's nothing I can do about it. That's actually the paper he wrote on my work. I'll just have to go on. Doesn't matter. This is a video of Jamie lifting a 64-gram ball, 2,000 RPM, I guess, with under 100 feet of copper. So conventional electrical engineering, I don't believe, could replicate that experiment. And we have it as a video. And it's my favorite video because he smashes the windings. And I really like rough housing. So if we have that video handy, John, if you'd play it for me, just because it's a good experiment because it shows the gauges, it shows the power, and that's the specifics right there. 2.4 volts, 1.53 amps. And when you have a second, put that on for me, that video of Jamie. It's referred to as flattened Rodin coil. I brought this for the fun of it because this is the first mandrel. It was made by Skeeter. He was a machinist extraordinaire, he referred to himself. He made the portable power pack that was on the moon lander, that left on the moon, the original one, and by the astronauts. He made it out of beryllium, dissimilar metals, sandwiched them together. It was in a lathe that was enclosed because it was deadly radioactive materials. And he sandwiched with a hole in the center. Anyway, he made this for me. Scott Gosler and Tom Dawson all worked together with me on this. And of course, this actually was wrong because everybody was trying to do the VW symbol. And it's actually a language. It's not actually the shape for the coil, because the VW symbol, if you know how to use it, which I call the mathematical fingerprint of God, I have a reason for that, is the language to make a toroid. It's actually a toroid coil. It turns out that there's an ideal toroid coil, and I'm using numbers as the schematic or blueprint. I'm not doing it by experimentation. Okay, let's see this video, please. That's a smashed Rodin coil.
Hey everybody, this is Jamie. What you're looking at right here is a flattened out formless Rodin coil. It actually came off of one of the yellow toroids. I built a standard 36 Rodin coil with 9 winds instead of 18. So this one was pretty much the same as this, but what I did was I took my X-Acto knife and cut out the yellow form, and then I decided just to mash the windings flat. and see what this
Smash it.
thing would look like, okay? So you can kind of get an idea. It's used to be a
Those
rodent
holes
coil,
are
or
very
it somewhat
important.
kinda
It
is.
requires no iron core.
Here's my neo
Iron
ball.
cores actually
The
get
coil's already
saturated
energized.
and make it weaker.
Let's see, let me get my thing hooked up here. I'll tell you what the
The toroid form is
So right
smashed.
now we've got 2.38, 2.39 volts.
So it's less
And
power
my
than a
ammeter here,
flashlight.
We've got 1.53 amps.
64 gram, 1-inch ball, N48.
And you see it, get it to start spinning. It levitates in there quite nicely. I can move it around, you know.
So he's suspending a
angle a little bit.
64 gram,
It seems to be
1-inch ball
pretty decent.
with just that little power.
Some good torque in there.
And under 100 feet of 24 gauge copper wire.
As you can see, it doesn't really, doesn't really look like much like a rodent
I've only
configuration,
picked
but
just
it
a
does,
handful of
you know,
videos.
to get a spinning ball.
Just a few.
So, anyway, just wanted to show that a
Because it
smashed,
should inspire you about the potential of the magnet, because I have a much more
smashed
denser
out rodent
magnetic
coil.
field.
This is a 36 coil.
Because I claim to found an energy in the center of the magnetic field that's not recognized today. And I claim that only the magnetism can respond fast enough to give slippage and free play to this energy, but I'm not going to go into it now. Okay, there is another video, because you're engineers, I know a lot of you are engineers of many backgrounds. Do we have Jorge's machine? Because it inspires my imagination when I see the application. So let's see one application. And there's been many thousands of videos made of applications. So we're going to look at, it's called maglev. God, I can't remember what he called it. I think the word was vortex in the video. But this is showing an application of the coil, getting rid of the iron core, getting rid of the brushes, getting rid of the commutator, almost getting rid of over 90% of the copper. The copper is the most expensive component. So, oh, that's it right there. That's the video.
Bring it to the front. There you go.
It's a long video, but I'll stop it once we get a feel for it. So there's no brushes, no commutator. It's suspended on a magnetic bearing. It's a Hall sensor in the center picking up. That is probably Delrin or something. There's an embedded small neodymium magnet in the shaft. So the only moving part is going to be the shaft, and it's going to be reinforced by the Hall sensor and driven by the magnetic field of the Rodin coil. And no iron core. Okay. It froze for a second, but that's, oh no, it's moving.
It's moving. It's playing.
Okay. So he's going to start it by just giving it a little touch. The noise gets deafening, and all you're hearing is a round cylinder spinning in air. Because there's such a dense magnetic field. It's the speed of the field. And it's just in training that magnet. It's like a magnetic wind that is so powerful and so fast.
It runs until it finds resonance.
17,000 RPM. $19,000 RPM. Okay, let's stop right there just because I'm watching time. It's going to be 20,000 RPM. The fastest they've gotten it is approximately 500,000 RPM. That's why we have the Delrin shields. Essentially, the saying is he who controls magnetism controls the universe. Okay, let's keep on going with the slides. And there's a way to control magnetism, and I do it with numbers. Okay, so we'll go to the next one. And thank you, John. That's my logo up there, times, divide, plus, and minus all in a circle. Now, it's not often, so I have this bizarre language that I invented. And it's existed before the Earth, and it'll exist when the Earth is gone. It's a part of creation. I essentially found the missing link between numbers and physics. Essentially, numbers are real, and nature is expressing herself with numbers. It's so bizarre. But this is why I'm showing this presentation. This is the Rodin number map. This was Greg Volk, and I just wanted to share it. We'll just keep going. He was able to take the numbers that I used, these number patterns and relationships, and put them on 3D geometric physical shapes. So next slide, please. This is a software that he designed. This actually is a coil manufacturing guide. I know that's unbelievable because this Excel sheet, if you put in the prime and square it, will tell you how many windings and where they go to make these coils. I know it's unbelievable that numbers are a language for motors, but it is. That's Greg Volk, the director of MPA. I don't know if that's his title, but he's the one who certainly oversees many things. Okay, next. So Greg Volk may still be here right now. He was here all this week. He became interested in my work because of the relationship of superstrings. And it turns out that I was doing prime squared. And that's based on someone else's work, Farron Thorpe's work, applying the vortex-based mathematics. That's a book I want to write, Opening Up the Black Hole. I never got funding, so I can never do it. And a video. It's preserving the work, and the work's not preserved, unfortunately. Okay, we'll keep going. But I was hoping to get funded for that. I don't follow conventional methods, which is to try and raise capital by offering shares or investment, because I don't want to get sucked into problems, and I probably would end up with problems. We'll keep going. It's a little blurry, so I'm just going to skip it. This is the Russell Blake's, why am I showing this artboard? It's blurry, and on top of it, if it wasn't blurry, it doesn't matter. It's incomprehensible. This is the director from Microsoft. He came to my house. This is the class he took, and his signatures are in it. This is the actual class, okay? And this is the math. It's bizarre. Let's see if I can find a signature. His signature's up in the corner. We're going to keep on going. There it is right there. Russ Blake, Heidi, the mother of my twins, and that's my name, and that's roughly 11/15/99. And here's a signature again. There's Heidi, and there's mine. Okay, what is significant about his signature on that is because I'm about to show you his resume, which he gave me to use, and I'm about to show you what he did with this math. There's his signature. And he has my blessings to do this, because I have no copyright and no patent on what I do. I just cannot become stuck in the mud, and so I don't use those existing modalities. Russell P. Blake, Microsoft Corporation, Senior Researcher, Advanced Technology, Systems Performance Manager, Advanced Operating Systems. That's a hardcore title for Microsoft. Advanced Operating Systems, Systems Performance Manager. Okay, what else is he? Okay, he wrote it's too blurry, I'm not going to try. But you're welcome to have any of these documents as well in the form of a PDF, although we're still organizing it. Sun Microsystems, Director of Operations. Adaptive Intelligence, Vice President of Engineering. Solaris Computers, Vice President, Software Development. So the guy's credible. He can say something, and it holds water. When I say I discovered a new language of math, it's bullshit, because I'm not qualified. I have no degree in math. When he studied my math, that's qualified peer review. So let's keep going. Towards a mathematical formulation of the Rodin torus. So he wrote, this is about a 70-page document. We're just going to go through it. We're not going to try and explain it. Okay, so we'll continue. He's generated hundreds of pages of documents. An introduction, I can't read it, it's too blurry. I'm just showing that it exists. Okay, analysis of the Rodin coil. So he went to applications, he did. He did a thorough treatment of my work. In fact, he devoted his life to my work. Let's keep going. Bear in mind, my endorsement is worthless. I have no credentials. Theoretical issues, he did a full treatment of it. Let's keep going. Electromagnetics, transformers, that's all what we're working on right here. Let's keep going. Bear in mind, I claim to get rid of the iron core. It's too bad it's a little bit blurry, but he says that it's an endorsement on my work. Let's just keep going. I kept his email. Next frame, please. I'm just going to cut through it. We're almost done, I hope. Not maybe. We still have a lot to go, but more letters, it's just too hard to read. It doesn't matter. You can take my word for it. They're unbelievable endorsements. Okay. We'll keep going. Here he says that he believes that my work is going to revolutionize. I am completely convinced that the Rodin torus will likewise lead to new and revolutionary advances. Here he says that he wrote formulae on my work, and he said that my work was not on the surface, but into the interior as well. In other words, my work was three-dimensional, he says right there. I have devised a math that models the z-axis perfectly. Combined with the inverse square law, essentially I can observe using this math the underpinning geometry of the universe, and I can find an energy that is the source of creation. You can call it dark matter, spirit, whatever you want to call it, tachyon, monopole. I know where it is, when it is, in relationship, most importantly, to magnetism and electricity. Let's keep going. the purpose of my explanation is just more letters, they're all from him, about my work. We'll just cut through it. The purpose of my presentation tonight is to share with you, Tyler, a friend of many of ours, let's keep going, found the patent that Russell Blake did based on the mathematics that he used, that I taught him. And this patent, I believe, is the secret of artificial intelligence. Now, it's not what we should be working on here, but I can't even read this document. Maybe some of you can, and I would furnish you with it, because I like your insight into it. The patent is under the radar. It's in his wife's name, and he says it's a board game. Believe me, it's not. If you go, it's back to his references, you'll see all his patents are on computer sciences. Okay? Microsoft is still paying him revenue on his patents. Okay, let's continue with his document. So what he did is he took this math, and this is how he expressed it. And it's actually an accurate way of doing it. Essentially, he says that I have the most coherence ever done in mathematics, that I have every axis possible, every point is connected to, I have an architecture where every point is connected to every other point. It's the most sophisticated processing ever done. It would, again, it would get rid of the PC, it would get rid of Apple. It's a whole other language, okay, that shows or uses the binary code correctly. But I'm not going to dwell on it. We'll just keep cutting through it. And this is all Blake's illustrations. So the greatest flattery is when somebody does something with your discovery. And he patented it. And it's a priceless application. Okay? Because again, I know the secret of artificial intelligence using this math. So there's, Peter put this together, different applications from antennas, field generator, it's just endless. Let's keep going. This is pretty much the end of my presentation. And I'm not going to just try and discuss how to make more powerful Rodin coils, but I will after dinner. And so these are just more things, DNA, genetics. My claims are completely outrageous. I claim to have the capacity, if there was research done on this, and if my work was properly documented so people could learn it, by creating a good, competent book. I had a book on it, I retired it because it was very difficult to write it and it's very difficult to read. It's too painful. So, and I always thought I'd get funding to do a better documentation. It just didn't happen. So, but it would end all disease, produce unlimited food. You can't believe the endorsements I get from Tom to the German Journal of Oncology. But I've always been an independent. it's just been my mindset. We'll just cut through it, whatever videos, pictures are left. Data compression. I have found the holy grail, or the cornucopia of mathematics. And a civilization is only advanced as its mathematics. And the mathematics that everyone is using today, you're never better than your tools. And the mathematics that you have learned is junk. Because I invented, discovered, found a form of math that is elastic. It expands and contracts. And the proper coils are not made out of copper. They're made out of a conductor, be it a plasma, an ionized gas, that expands and contracts from the ID to the OD. It gets bigger to the OD, like a wavy bow tie. There's so many components that can be integrated into a coil that would greatly enhance its results. Essentially get rid of friction, get rid of parasitics, literally make the coil an energy source that you could take anywhere, that you could take into space, that you could power any city. It's unlimited power, and that's a hell of a claim, and I'm not kidding. And and I didn't show one other person's. I'd like to show Daniel's. We'll just cut through this and finish up. That's a glass toroid, because I believe in making them with plasma. We're going to show what Daniel's doing, because I wanted to help Daniel come here, and I really didn't have the money to do it, and I'm very sad that he's not here, because he would have had hardware for you. And Steve really likes us to show hardware. And so Daniel is able to, as he'll say right now, what he's able to do. So if we have the video, he put this up on the internet. These are many different people taking the designs and evolving.
Change is necessary, for we are on the path of destruction.
This is his wife. She makes all the coils.
Technologies must be implemented so we can move forward.
There is a global consensus that people are ready for change. The Unification coil has the ability to facilitate that change in a very real and practical way.
My name is Erica Nunez, and I am the co-creator of the Unification coil.
In order for us to embark into a future of a truly sustainable energy efficiency, we need to take into account the torus in particular. Our bodies are toroidal systems, our planet is a toroidal system, and all vortex energy works in the same fashion.
This technology has been around for centuries.
We stumbled upon the vortex math of Randy Powell and Marko Rodin and began to expand on their concepts. My name is Daniel Nunez, and I am the co-creator of the Unification Coil. This is our Unification Coil technology. It
Someone ran after you with that, I'd run.
Vortex-based mathematics, sacred geometry, and electromagnetism all in one. We're able to create implosive magnetic fields that then serve as a reservoir of self-regulating energy. In this demonstration, we're using a 12-volt battery which feeds into a simple circuit that creates a sound frequency. That sound frequency is then fed into the coil, and then it comes out in the form of usable light. Now, the important thing here is that we're able to light 98 LEDs at a fraction of the energy consumption that it would normally take to light around 8 LEDs. So we're getting 90 more LEDs for less energy consumption.
What once began as a simple nightlight has now evolved into a device that has the potential to change the world.
In short, the Unification Coil will revolutionize many industries.
So he just said that he lights 98 LEDs with the power of 8 LEDs. And it's just endless, everybody having applications that are, it's called a jewel thief. There's just endless accomplishments. But it's, thank you very much for having me as your guest. I hope you help us explain it. I like your explanations. You better take it off. If you have questions, it can be after dinner.
I tell you what,
But you,
Marko, are you going out to the
Yes,
social
you
with
got
everybody
one.
else?
yes.
Okay, we're going to take some Q&A out in the social. Everybody's hungry. Don't go out that way. The social is out that door, back door right there. Just go straight out, and the food is waiting. There's veggie wraps, chicken sandwich, ham and salami sandwiches, potato chips,
How many
food,
years ago was that?
fellowship, you name it.
Yeah.
And whenever you're ready, just come on back in and filter in back through that door tonight. It's the only time you can do that, but you can come in back through that door, and we'll just start doing the Rodent Clinic when everybody gets some groceries.